Welcome, my friends. In this video, I'll be discussing Section 6.5, Association and Causation. It's very important to differentiate between correlation and causation. A strong value for the correlation coefficient, near 1 or negative 1, says nothing about whether or not one variable causes the other. A strong correlation tells us that our x, or independent variable, does a good job at predicting y, or our dependent variable, but it does not tell us for sure that x actually causes y. Thus comes the mantra, correlation does not imply causation. However, the first step that you might take to show causation might be to show correlation. And then you might want to design an experiment to tell for sure whether or not there is causation. In an experiment, we can control for lurking variables and isolate one variable to see if it's causing another one. So when we have the correlation coefficient, we usually just have observational data. We typically have not ran an experiment. So typically we're not going to be able to show causation based on this type of information. Here is an extreme example to show the point. Our explanatory variable is sunscreen sales, and our response variable is ice cream sales. And here we can see there is a strong positive correlation between sunscreen and ice cream sales, but there's not a causal relationship. The days when we have more sunscreen sales also tend to be the days when we have more ice cream sales, but we wouldn't say that the sunscreen sales are causing the ice cream sales. We have, of course, what is called a lurking variable, which we've discussed in other videos, which is probably responsible for this relationship. And the lurking variable here is probably temperature. So the days when we have maybe a higher temperature, we would also have more sunscreen sales, but at the same time, we would also have more ice cream sales. So it would be a mistake to say just because we have correlation here, we also have causation. The best way to show that we do have a causal relationship would be to design an experiment, which would be kind of silly in this case, but in many other cases, you might be led to believe that there is a causal relationship just based on the scatter plot. And really what you should be doing to show that for sure is design an experiment. Now, in many cases, you could also have what is called reverse causality. So in many cases, we might set up a problem in such a way that we think that our independent or explanatory variable is causing our response variable, or our y variable, but the reverse could also be true. So here's kind of an interesting example of when that could be the case, right? So let's say that our x variable is the number of police officers that are in a city per person. So like per person, how many police officers are there? And then y could be the reported crime rate per person in the same city. So we're doing per capita here, so it kind of controls for city size. So suppose that there is a positive correlation between these two variables. What that would mean is the cities that tend to have more police officers also tend to be the cities that have a higher crime rate. And there's a number of possible explanations for this. So one possible explanation would be the straightforward X is causing Y type explanation. And that would say that when we tend to send more police officers into a city, that actually increases the crime rate. And the reason why that might make sense is because if you have more police officers there, then they're going to be catching more of the criminals. So the crime rate kind of de facto is going to be increasing because we have more police officers there to catch the criminals. So that's one possible explanation. But it could be the other way around. It could be that Y is actually causing X, what we call reverse causality. It could be that the areas that already had higher crime rates to begin with caused us to send more police officers there. So when we observed cities that had higher values of Y, higher reported crime rates, we said, oh, we need to go ahead and send more police officers there to catch more of the crime. So it could go, X causing Y, or it could be the other way around, or it could be a little bit of both. And that's what I'm saying right here. So maybe both are true to one extent. So it doesn't always have to necessarily be one answer. There can be many different things that can come together to cause something. And sometimes it could be, the straightforward causing, X causes Y, it could be reverse causality, it could be a lurking variable, or it could be a combination of all of those different things. So causality is a very, very tricky thing to get at. And people today seem to be a lot more, they like to jump to the conclusion that one thing is causing another maybe more quickly than they should. Okay, the last thing I want to show here is there is a website that I think is pretty interesting here. It's called Spurious Correlations. And it just shows a number of examples of things that are highly correlated, but clearly not causally related. And I have not looked at this before the video in terms of what they have updated this, but they have recently updated this website and put on some new examples here. So let's see what they have. So apparently they got Google searches for report of UFO sightings. Apparently correlates with kerosene use in South Korea. And a lot of these are doing it like across time here. So that's kind of interesting. Let's see what else we have. Cost to send a letter via the USPS, or the United States Postal Service, correlates with Google searches for I am dizzy. So obviously, like these don't have anything to do with each other, but they're both kind of going up in the same case. A lot of times, the lurking variable in a lot of these is probably population. Let's see what else we have. Associate's degrees awarded in business management apparently correlates with popularity of the scumbag Steve meme. Now I'm curious. I don't even know what that is. But apparently those, is this what it is? I don't know, some Gen AI things. But anyways, you can go ahead and, look through some of these, and some of them can be quite interesting. But the main takeaway is just because you observe correlation, don't necessarily jump right to saying there is a causal relationship. All right, that's all I had to talk about in this video. I will see you in the next one.